Capitalized Math and History, and we're gonna do a video on common types of histograms. So in the past videos, we have been taking a look at data, statistics, and a whole bunch of other data. And we have been talking a lot about charts, graphs, and histograms. But we're gonna talk about the different types of histograms. So, a histogram is a type of graph or a type of chart that measures the frequency but groups them in a specific order. The left side is closer to 0 while the right side has a closer value to a number that's larger. So it goes from 0 to how long you want to count for. And these bars represent groups. So here's an example of a histogram. This example is a symmetric histogram because it looks just like an even mountain. And with that histogram, we're going to see how the type of the histogram is going to affect the mean and the median. Remember, the median is basically add up all the numbers that you have, like 1, 2, 4, and divide by how many numbers there are. So 1 plus 2 plus 4 divided by 3, that's 7 over 3, so that's our average. We leave it as a fraction. But if you want to look at the median is not really affected by the type of chart you use or the histogram, but it's still going to be a big play in the game. So remember, the median is actually what the two middle numbers are in numeral order, like 10, 12, 4, and 16. 10 and 12 are going to be the middle numbers. So you have to add the two. That will bring you to 22, divide by 2, and 11 is going to be our middle number. If you have an odd number of numbers, then you have like 3, 6, 9, then 6 would be the median because it's the middle number. So, going back to the charts, with a symmetric type chart or histogram, it has the median and the mean on the top of the mountain because the numbers of bars is equal to the other side of bars to get up to the middle. So pretty much the mean and the median are going to be the same because the average is going to be at the top because they're the most. And 2, the median is going to be at the top because there's an equal number of bars on each side. Here's an example where a symmetric histogram would work. So if you ever heard about IQ, that means intelligence quotient, and that also measures how capable your brain is to figure out puzzles and think logically, and it'll also see how talented you are. So in the USA and some other countries, the average person has an IQ of 100 IQ. If you go down to the bottom, this is around 80 and 70. The lowest IQ recorded was 59, so it's closer to this side. But if you are gifted in any subject or you're just gifted in your own talent, then you're going to go to the right because that means more. Like 120 actually means moderately gifted. Or if you're 180, that is highly gifted. My favorite person who is a mathematician has an IQ of 230. So basically, he's off the chart. And his name is Terence Tao. So, he's famous for discovering and proving over 30 math theorems. He currently works at UCLA. So, if you have an IQ of 230, then wow, that's a high intelligence quotient. So, IQ can be a great example of a symmetric histogram, where it looks like the shape of a mountain and the mean and the median are at the top. Let's take a look at the next type of histogram, which is called a skew-left. A skew-left is another type of histogram, but the reason why it's called skew-left is because this part, which looks like the tail, is pointing directly left. And the mean and the median also change, but the median doesn't change because the number of bars or the numbers of numbers to find the middle number is going to be around up here. But the average or the mean actually does change because the reason why it's not here and it's down toward here, because even though there are a lot of bars that raise up right towards the sky, there are even more number of bars that are raised down lower, which means your average will drive itself towards the lower numbers, towards 0. Because your average is going to be affected because there are more bars that are smaller in height and in frequency, because that's the number of how many of what you're calculating. There are much more smaller ones than much larger ones. So these right here are going to drive the average towards the left of the histogram. So the mean or the average is going to be on the left side of a skew left. Here's an example where a skew left histogram would apply in real life from a video game. So that game in Pikmin 3 is a great example of a skew left because the majority of the players score between 2 minutes to 0 minutes. The world record was 1 minute and 4 seconds just to beat a boss battle, but it's very, very rare for people to take like 10 minutes and 13 minutes just to complete a boss battle in Pikmin 3. So that is an example of a skew left. Let's look at the last common histogram and see what that one is, because it's the opposite of a skew left. This one is called a skew right because the tail is pointing like an alligator towards the right, which means the mean is also going to be on the right side because there are more bars that are smaller that are on the right side than bars that are taller on the left side. It outnumbers. So, since these are bigger value bars, but they are not that tall, the mean or the average is going to go to the right because these ones over here will have high numbers, which means that it will be driven to this side. Some of these, which may have really high outliers, but the median does not change because it's still the same number of bars, so it's going to stay at the middle. Here's an example of a skew right. So, the example is, if you live in a state, most houses will be in the range of 500K or around 400K or 600K. Based on your state, your prices for houses might be within that area, but the small bars over here are actually going to cost a lot more money, like 1 million, 2 million, probably like 900,000, 700,000. So even though that there are not that many houses that cost that much, it will drive the mean or the average of the house cost and the budget to the left because the cost for the much larger houses, which may be mansions, may have a lot of money that you need to buy, and there are a lot of houses that are in the 500, 400 range in thousands, but having a lot of houses in like the 700, 800, 900, possibly a million, possibly 2 million, is going to be around here. So it's going to drive the mean this way. That's an example of a skewed right. I hope this video has helped you learn about the common types of different types of histograms. I hope this video has helped you. Thank you for watching Helping Your Life's Math Industry. Like and subscribe.